Okay, so good evening, everyone. And today we're going to start discussing some questions from week 7 lectures. So, first, we'll be solving some questions from potential function, which has been taught in the live classes, I mean, in the week 7 classes. So, first, you're going to write the first question. Uh, so, the question is given like this. Okay, so find out the potential function for the vector field if y equals to 4xy plus y square of z I cap plus 2x square plus 2xyz plus z square j cap plus xy square plus 2yz into k cap. Okay, so for this given vector field or for this given vector function, we have to look for our uh, scalar function phi such that f equals to gradient of phi. Correct. So now we're gonna do the solution. And if you want to give a try, you can pause the video. Otherwise, we'll move forward. So, okay. So, so first we're gonna give the definition of the vector field, then and the process how to find out that vector field. I mean that potential function such that f equals to gradient of phi. Okay. So let phi be the potential function corresponding to the vector field f corresponding to the vector field f. Okay, and then uh, f of then f cap equals to uh, gradient of phi. So this will be phi. Okay, so here f is given by 4xy plus y square of z I cap plus 2x square plus 2xyz plus z square j cap plus xy square plus 2yz k cap. Okay, and this will be equals to del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. Okay, so now we have two vector field, one on the left side which is f bar, I mean the f, and on the right side which is the gradient of phi. So that means we can equal the component. I mean we can compare the component of both the sides. Then we can write that uh, del phi by del x equals to 4xy plus y square of z. Correct? So now we can do integration with respect to x. So this is going to be phi of xyz equals to integration 4xy plus y square of z. So since we are doing the integration with respect to the variable x, so the other two functions, I mean other two variables and y and z will be constant. So that means the constant which will appear after the integration will be a function of y and z. So this will be phi 1 of y comma z. Okay. So now we can do the integration simply with respect to the variable x. So this will be 2x square y plus xy square of z plus phi 1 of y comma z. Okay. And then again we can we can see that del phi of del y. So now we are comparing the y component. So from here we can see this is 2x square plus 2xyz plus del phi 1 by del y. Okay. So now we can put the value of del phi by del y from here. So which is 2x square plus 2xyz plus z square. And this is same as the right side, which is 2x square plus 2xyz plus del phi 1 by del y. Okay. So now from here we can see that del phi 1 by del y is z square. Okay. So now again we can do the integration with respect to y. So in this case phi 1 of yz, this is gonna be z square plus phi 2 of z. Okay. So this will imply z by 3 plus phi 2 of z. Okay. Okay, fine. So now uh, this so we are doing with respect to the variable y. So this is gonna be yz square plus phi 2 of z. Okay. Again, so from here phi of xyz, so this will be equals to 2x square y plus xy square z plus yz square plus phi 2 of z. Okay. So now again we can do the integration differentiation with respect to z, that is del phi by del z. So this is gonna be 0. So this will be xy square plus 2yz plus phi 2 prime of z. Okay. So now we can compare this del phi of z, which is xy square plus 2yz. So this will imply xy square plus 2yz. This is same as xy square plus 2yz plus phi 2 prime of z. Okay. So this is implying phi 2 prime of z equals to 0. Or in other words, phi 2 of z equals to constant. Okay, because phi2 of z equals to integration of 0 dz plus constant, which is just constant. So our potential function phi is given by 2x square y plus xy square z plus yz square plus c. Okay, so this is our given potential function. I mean, this is our required potential function. So even we can do the derivative of, I mean, we can take the gradient again, and we can try to see that f will be gradient of phi or not. So for example, if you take this nabla of phi, so this is nabla of phi, then this is gonna be I del x plus j del y plus k del z, correct? And then 2x square y plus xy square z plus yz square plus c. And if you do that, you'll get 4xy plus y square of z into y cap plus 2x square plus 2xyz plus z square into k cap and plus xy square plus 2yz into k cap, right? And which is our given f. So from here, uh, we can verify that our potential function is correct because f equals to gradient of phi is coming. So this is our phi. I mean, this is our f. So yeah, this is our f. Okay. So I hope this is clear. This was an easy question. Okay. So now we're gonna go to the next question. So is there any doubt in the previous question? Is there any doubt? Okay. So then we're gonna move forward to the next question. This is also to find out the potential function for a given vector field F. So find out the potential function for the vector field if r equals to xy minus y to the power 4 into I cap plus x square minus 3xy cube into j cap. Okay. So now we're gonna do the solution. So if you want to give a try, you can do with me also. So otherwise, I'm gonna do the solution. So what is mean by a potential function? So a potential function is a scalar function, okay, such that if you apply the gradient, then you will get our given vector field F. So that means let phi uh, be the potential function. Potential function associated to the given vector field A bar, then this f cap equals to, or the vector f is uh, gradient of phi. Okay. So now what is f? So f is given by xy minus y to the power 4 of y plus x square minus 3xy cube into j cap, and this is same as del phi of del x into I cap plus del phi of del y into j cap. Correct? So now we can compare both the left hand side and the right hand side, and we can see that. So let us call it star. So from star we have del phi of del x equals to xy minus y to the power 4. Correct? So that means phi of xy equals to integration xy minus y to the power 4 dx plus phi 1 of y. So since we are doing the integration with respect to x, so we're going to treat the variable y as a constant. So that means the constant function after the integration will be a function of y instead of simply a constant. Okay, because there are two variables x and y. So suppose if there were three variables x, y, and z, then this phi 1 will be phi 1 of y comma z instead of phi 1 of y. Okay, so this is just x square by 2 y minus xy to the power 4 plus phi 1 of y. Okay, and then again we have another del phi of del y. So we're going to use that information here, and for that reason we're going to do the derivative with respect to the variable y. So it will be del phi by del y, and this will be x square by 2 minus 3xy cube plus phi 1 prime of y. Okay, so now you go to the star here. So here you see that del phi by del y is x square minus 3xy cube. Correct? So we're gonna compare it with this. So this will be mm, so this will be x square minus 3xy cube equals to x square by 2 minus so it was 3xy cube, right? Yes, 3xy cube plus phi 1 prime of y. Okay, so that means uh, our phi 1 prime of y is x square by 2, sorry, and it was 3xy cube, right? So this will be 4, not 3, because the derivative of y to the power 4 is 4y cube, right? So it will be 4xy cube. So x square by 4, and this will be also 4. So x square by 2 plus xy cube. Okay. So now we can do the integration with respect to y. So this will be phi 1 of y equals to uh, integration of x square by 2 plus xy cube plus c. So now since there are only one variable y, so after the integration we'll get only a real constant, not any constant function of any x or y. Correct? So this is gonna be x square y, sorry, x square y by 2 uh, plus, so this will be x y to the power 4 by 4 plus c. Okay, so our phi of xy is, so yeah, let us see here. So it was x square by 2y minus xy4 plus phi 1 of y. So this is x square y by 2 uh, minus xy4 plus x square y by 2 plus xy4 divided by 4 plus c. Okay. So this is gonna be x square of y uh, plus xy to the power 4 1 minus 1 by 4 plus c. So this will be x square of y plus so this will be 3 by 4 xy to the power 4 plus c. So if the question is correct, the potential function should be, so the required potential function phi is phi of xy equals to x square y plus 3xy to the power 4 divided by 4 plus c. Okay, so this should be the answer. Is it clear? So I can go through once again if there is any doubt.
No, this is fine.
Okay. So thank you. So yeah, now I think probably I'm gonna write some simple theories how to verify if like if the potential function exists or not, like the existence of potential function phi. So yeah, so let me write it here. Okay, so let uh, d subset of R3 be simply connected domain. Okay, and if from D to R3 be a vector field. Okay, so uh, let me write the vector field explicitly. So the vector field looks like this: f of xyz equals to f1 of xyz I cap plus f2 of xyz j cap plus f3 of sorry f3 of xyz k cap. Okay, then we say that there exists a potential function there exists a potential function corresponding um, to the vector field f if and only if. So anyone, any guess what it can be? Like what is the condition such that given a vector field, its potential function always exists? I mean that scalar function phi such that f equals to gradient of phi. Anyone? So the condition which is defined that given a vector field f, its potential function exists is curl of f is 0. Okay, so the proof of this theorem is easy for one side, because if f equals to gradient of phi, so for example, if f equals to this nabla of phi or gradient of phi, then this is easy to see that curl of grad phi is 0. Okay, but the other part of the proof, you have to see some standard book, because I'm not going to do the proof here. It's a long proof. So if the curl of f is 0, then f can be written as a gradient of phi. So you have to use some kind of Stokes theorem and other results. Okay. So now what is curl of f? Curl of f is easy to write. So curl of f is, this is I, j, k, and this is del x, del y, and del z, and this is f1, f2, and f3. Okay. Now if this curl of f is 0, then we can say that f can be written as gradient of phi. Now in case f is a vector field of dimension 2, like f is a vector field from R2 to R2, or from D subset of R2 to R2, where D is a simply connected domain. So just like written like this, f1 of xy plus I cap plus f2 of xy j cap. Okay, so f is a function from D to R2, where D is also simply connected. So simply connected means if you take like any curve or like any Jordan curve inside the domain, then all the domain should be, I mean, all the region inside this curve should be a subset of that same domain. Otherwise, it is not. So I'll give an example of a domain which is not simply connected. Okay, so don't worry about it. Now, for example, if f is a function like this of two variable, then we can say that f equals to gradient of phi. Then if and only if, so this is I, j, and this is k, and this will be del x, del y, del z, and this is f1, f2, and 0. Correct? So from here, one condition we can draw that curl of f is 0 implies, so this will imply that del f2 by del x minus del f1 by del y equals to 0. Okay, and this will imply that del f2 by del x equals to del fn by del y. So if is a function from D subset of R2 to R2, then f has a potential function, or f can be written as gradient of phi if and only if del f2 by del x equals to del f1 by del y. Okay, so we're gonna see some example right now, and then we'll verify that for this type of function if this condition holds or not. Okay, now one thing I want to mention here is that the domain should be simply connected. Okay, this is very important. If this domain is not simply connected, then we can say that that this theorem may not hold. Okay, so I'm going to give a counter example, so you guys can verify later that if the domain is not simply connected, then f may not be written as a gradient of phi, even though the curl of f is 0. Okay, so domain D, so this is as note, D should be simply connected uh, Otherwise, the above result may not hold. Okay. So the example is you take d equals to r2 minus 0 comma 0. Then d is not simply connected. Okay. So what is this domain? So you take whole R2 plane, but you remove this point. Okay. So this remove is not included. This point is not included. So you take whole R2, but remove this point 0 comma 0. So now since this domain is not simply connected, because if you take any circle whose origin is 0 comma 0, then this inside region will not be a subset of D, because 0 comma 0 is not included in the domain. So that means D is not simply connected. Okay. And you define the function like this. So you take the function f from D to R2 given by f of xy equals to uh, minus y by x square plus y square I cap plus x by x square plus y square j cap. Okay. So now it is easy to verify that curl of f is 0. Okay. So try to verify that curl of f will be 0, but f is not equals to gradient of phi for any scalar function phi. Okay. So this is an exercise also, I can say. So try to verify that the curl will be 0. However, this f cannot be written as a gradient of some scalar function. Okay, because you can prove it using contradiction or the method of contradiction. So suppose if it holds for every phi, then you get some contradiction that the function should not be written like this. Okay. So I hope these results will be useful later. So just remember the domain should be simply connected. Then the vector field has a potential function if and only if the curl is 0. Okay. So I hope this is clear. So now we're going to solve some question and we'll try to see how to apply this type of theorem. Okay. So yeah. So first let us take this example. F bar equals to 4xy plus y square of z I cap plus 2x square plus 2xyz plus z square j cap plus xy square plus 2yz k cap. Okay. So now we're going to try to find the curl of f, which is this gradient cross product of f. So this is going to be I, j, and k. Okay. And so this is del x, del y, del z, and this is 4xy plus y square of z, and this is 2x square plus 2xyz plus z square, and this is xy square plus 2yz. Okay. So now we can try to evaluate this curl. So first this will be I of. So we can try to evaluate this determinant. So this is going to be 2xy minus 2z, 2xy plus 2z. Sorry, not minus. Minus of then it will be 2xy minus of 2z. Okay, correct. Minus of j cap. So this is going to be y square uh, this will be y square plus 0. So simply y square, okay, or plus 0. And then again negative of minus of 0 minus of y square plus k cap, and this is gonna be 4x plus 2yz minus of this will be also 4x minus 2yz, correct. So now from here we can see that this is all getting cancelled out, correct. This 2yz 2yz 4x 4x, so all are getting cancelled out. So this is going to be simply I into 0 plus c into 0 plus k into 0. So this is ultimately 0. So this should happen because this question we solved in the beginning, and we showed that for this given vector field the scalar function or the potential function exists. So if the potential function exists, the curl should be 0. Okay, so that's why this curl is becoming 0, because it has a potential function, and we have already evaluated this potential function here. So this was our potential function phi. Okay, so that's why this curl is 0. So yeah, I hope this is clear. So this should be a 0 vector. So now let us try to see another question. Is there any doubt for this question? Anyone? Yeah. Is there any doubt? I think this is clear, right? According to the result, or according to the fact we have just given. Okay. So yeah, let us try to write another function, and we're gonna see that for this function, our curl is not 0. So that means its potential function do not exist. Okay. So yeah, let us try to write if bar equals to, I mean if cap equals to xy minus y to the power 4i plus x square minus 3x y cube into j cap. Okay. So this f1 of xy is um, xy minus y to the power 4, and f2 of xy is x square minus 3x y cube. Okay. And then till f1 till y. So what was the theorem? So it was, yeah, del f1 del y equals to del f2 del x. So this should be x minus 3y cube, and del f2 del y equals to also, so this is del x 2x minus 3y. Okay, and in this case del f1 del y is not equals to del f2 del x. Okay, so now let us write the next question. So examine the solenoidal field out of the following. Okay, so the first question is if one of x, y, z, this is equals to x plus y of I cap plus 2y minus 3z of j cap plus 3x minus 4z of k cap. Okay, so solution. Now a vector field F is called solenoidal if anyone, when a vector field F is called solenoidal. So if its divergence is zero, right? And it's called conservative if the curl is zero, correct? If divergence of F is zero. Okay. So now we'll just simply calculate the divergence and then we are done. So this divergence of F1 is just tilde x of x plus y uh, plus tilde y of 2y minus 3z uh, plus tilde z of 3x minus 4z. I hope this is clear. And this is just 1 plus 2 plus sorry, minus 4. So this is 3 minus 4 which is just minus 1, and this is not equals to 0, correct? So F1 is not a solenoidal field. Okay, is this clear, everyone? Is this clear? Okay, so I assume everything is clear. So the next function is given by F2 of xyz equals to x minus 1 of x minus y of I cap plus 2y minus z into k cap plus 3x minus 4z. Sorry, this will be j cap, and this is 3x minus 4z into k cap. Okay, so we'll simply just calculate the divergence. That's all. So divergence of F2. So this is simply uh, del x of x minus y plus del y of 2y minus z plus del z of 3x minus 4z. Okay, so this is going to be 1 plus 2 minus 4. Okay, so this is again minus 1, so not equals to 0. So not a solenoidal field. Okay, so this is the last question from the solenoidal field, which is C, and this is given by F3 of xyz equals to 2x minus 2y of I cap plus 2y minus z of z cap plus 3x minus 4z of k cap. Okay, so here divergence of F3. So this is gonna be del x of 2x minus 2y plus del y of 2y minus z plus del z of 3x minus 4z, right? So this will be 2 plus 2 minus 4, which is 0. So F3 is a solenoidal field. Okay. Is this clear up to this question number 3? Okay. So I hope this is clear now. This is not that difficult. So now I'm going to move on to the next question, which is question number 4. So this is from the relation between the gradient and the function r. So basically you have to calculate the gradient of some r inverse or r cube or 1 by r. This is just from the BSc third year, I mean BSc third semester or fourth semester classes. So calculate the value of grad of 1 by r, where r vector is given by x I cap plus y z cap plus z k cap. Okay. So you guys also can try to do the solution with me. If I am doing anything wrong, you can just let me know. Or if you guys are like have any doubt, also you can ask any question at this point, at any point. Okay. So gradient of phi we all know, right? So this is just the gradient operator. Uh, I mean simply del phi del x into I cap plus del phi del y into j cap plus del phi del z into k cap, right? Where phi is a scalar function. Okay. So what is r? So r is just the distance from the origin, which is just square root of x square plus y square plus z square, right? So our phi is given by 1 by r because we have to find out the gradient of 1 by r, correct? So this is just 1 by square root of x square uh, plus y square plus z square. Okay. So now uh, del phi by del x. So this is will be minus 1 by 2 times square root of x square plus y square plus z square into del x of uh, x square plus y square plus z square. Okay. So this is minus of 2x by 2 into square root of x square plus y square plus z square. So 2 will get cancelled out. This will be just minus x divided by square root of x square plus y square plus z square. Okay. And then again, del phi of del y is minus of y divided by square root of x square plus y square plus z square. Okay. Similarly, del phi by del z is also similar, same as minus of z divided by square root of x square plus y square plus z square. Okay. So our uh, gradient of phi, which is gradient of 1 by r, and this will be uh, So I think I made some mistake here. So this will be whole cube. This integration will be whole cube, not okay. So this will be just whole cube because you just do the derivative with respect to the variable x, putting that y and z to be constant. So this is just minus x by r cube minus y by r cube, and this is minus z by r cube. Okay. So this is del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. Okay. So this is minus x by r cube I cap plus y by r cube j cap plus z by r cube k cap. So this is simply minus of r divided by r cube because r cap is just xi plus yj plus zk. Okay. So gradient of 1 by r should be r divided by minus of r divided by r cube. Okay. So yeah, I hope this is clear. So now we're gonna go to the next question. Question number 5. Okay. So let u cap equals to minus of xi cap plus yj cap plus zk cap, and v bar equals to also yz square of I cap plus xz square of j cap plus 2xyz k cap. Now if u cap and v cap are irrotational vector satisfying the relation this is divergence of u cross v plus f cross sorry divergence of u uh, plus u dot v equals to 0. Okay. Then what is the value of the scalar function f? So now yeah, you guys can give a try if you want to solve. So this is just simply is an easy question because already u and v are given, and they are irrotational vectors, and they are just satisfying some relation, and you have to just find out all the value like u cross v, this gradient of the gradient divergence of u dot v, and then you have to put all this here. So let us call it as 1. And then if you just put it all there, then you will get your required f. Okay. So first we're gonna calculate this u cross v. Okay. So this is gonna be just I j k, and u is given by minus x, y, z, and v is given by yz square, xz square, and 2xyz. Correct? So this is just we have to calculate the determinant. This is I cap into 2xy squared z, 2xy squared z minus xz cube uh, minus of j cap. So this is minus 2x square of yz minus of yz cube plus k cap minus of x square z square minus of y square z square. Okay. So now we have to calculate the divergence of u cross p. So this is just del del x of 2xy square z minus xz cube to xy square z minus xz cube minus del y of um, so this will be minus minus plus, so we can take the minus out. So or maybe just you can keep it minus 2x square yz minus of yz cube plus del z minus x square z square minus y square z square. Okay, so this will be just 2y square of z minus of z cube. So this is plus 2x square of z plus of z cube, and this is minus 2x square of z minus 2y square of z. Okay, so this is 2x square z and 2x square z cancel out. 2y square z, 2y square z get cancelled out, and z q also get cancelled out. So we have only 0, correct? So this term becomes 0. Okay. So now we have to find out the divergence of u. So uh, divergence of u is del x of minus of x, because u was minus xi plus yj plus zk. So not phi. This will be del x of minus of x plus del y of y plus del z of z. This is minus 1 plus 1 plus 1. So this is sorry, minus 1 plus 1 plus 1. So this get cancelled out. So we have only simply 1. And again u dot u dot v. So the dot product between u and v is just minus xyz square plus xyz square and then again plus 2xyz square. Okay, so this is gets cancelled out. So 2xy z square. Okay, so now again we have to just put all this value here. So from 1 we have, so we already have this divergence of u cross b to be 0. So this is gonna be 0 plus f times. So what is u dot v? Sorry, divergence of u. So divergence of u is just 1. Okay, and then u dot v is 2x y z square, and this is all 0, correct? So from here we have f equals to minus 2xy z square. Okay. So if the question is correct, the answer should be minus 2xy of z square. So from 1, f equals to minus of, okay. So this should be the answer for this given question. Is there any doubt from this question? Anyone? Okay. So if there is no doubt, then I'm going to write some fact. So yeah, is this true for every vector A and B? Is it true? So is this true for every vector A and B? Anyone? Okay. So yeah, indeed this is true for all A and B. Okay. Because for example, if you take A to B like A1 of I plus A2 of Z plus A3 of K, and B to B B1 of I plus B2 of J plus B3 of K, then A dot B is just A1 B1 plus A2 B2 plus A3 B3, right? And this is same as B1 A1 plus B2 A2 plus B3 A3, right? And this is same as B dot A. And this is true for all A and B because our A and B was arbitrary, correct? So this result is true. Now what about this one? Yeah. So is this true for every A? So here this nabla is just the gradient operator. Like, is this true for every like A and B? I mean, for every A and this gradient operator. So the answer is no. Okay. So this is because see that this nabla of A is an operator. So this nabla is an operator which we are applying on A, right? So this is kind of applying del del x on A1, del del y on A2, and del del y del del z on A3, right? So this is something like this: del A1 by del x plus del A2 by del y plus del A3 by del z, right? And of course A is given by A1 of I plus A2 of j plus A3 of k. Okay. Now what about the other one? What about this one? So this is just A1 of I cap plus A2 of j cap plus A3 of k cap dot product with I del del x plus j del del y plus k del z, right? So this is just a1 into del del x plus a2 into del del y plus a3 into del del z, right? So from here we can see that this may not be equal. Sorry. Okay. So I hope this is clear now. So is there any doubt now? Yeah. Any doubt? Okay. So if there is no doubt, then I'm gonna move forward to the next question. And it is given like this. So this is from line integration. So I hope line integration was taught in this week. And we're now gonna see some questions from line integration. So yeah, whenever it is necessary, I'm gonna write the formula to find out the line integration. So find the value of the line integral. Just okay. Where if cap of x, y, z, this is given by 2y plus 3 I cap plus x z j cap plus y z minus x of k cap. Okay. And C is the straight lines from 0 comma 0 comma 0 to 0 0 1 then to 0 1 1 and then to 2 1 1. Okay. So yeah, solution. So in this line integration question, three different path is given, which is like joining from one point to another point. Like first from 0 comma 0 comma 0 to 0 0 1, and then 0 0 1 to 0 1 1, and then 0 1 1 to 2 1 1. So do we have three different paths? We can call it C1, C2, and C3. Then C is just sum of that three paths, C1 plus C2 plus C3. Correct? So now before solving this question, I just want to write some basic things like, so for example, if f becomes conservative, then this integration become independent of the path of the integration, and then we can write in terms of the potential function, right? The integration and the line integration in terms of the potential function. Okay. So for example, if f equals to uh, gradient of phi, then this f dot dr. So this is just phi of the final point minus phi of initial point. Okay. So this is also one kind of things you can find out if f can be written as a gradient of phi. And in short, we can calculate the curl of f if curl of f is 0. We have seen in the previous result that if curl of f is 0, then f can be written as gradient of phi. And if f can be written as gradient of phi, then the line integration over any c is easy to find because it will be just phi of the final point minus phi of the initial point. Okay. So now let us try to see that in this case if like curl of f is 0, if curl of f is 0, then it has a potential function. If curl of f is not equals to 0, then we have to use the traditional formula. Okay. So curl of f is, so this is gonna be I j k del del x del del y del del z, and then 2y plus 3 and then xz, and this is yz minus x. Okay. So now if curl of f is 0, then f is just gradient of phi. Then we're going to calculate the gradient of phi, and then we can easily find out the line integration. So that's why it is very necessary to check if the curl of f is 0. Okay. So this is just I times z minus x plus j times minus 1 uh, minus 0 plus k times. So this will be minus plus k times z minus 2, correct? And which is clearly non-zero. So from here we can say that curl is not 0. So that means f is not conservative, and f is not, of course, uh, gradient of phi. Okay. So that means we have to calculate the line integration over these three different paths, like C1, C2, and C3, like joining of these 3 points. Okay. So in this case, this C of f dot dr, this is just C1 of f dr plus C2 of f dr plus C3 of f dr. Okay. So now what is C1, C2, and C3? So C1 is just a straight line. So a straight line joining from 0, 0, 0 to 0, 0, 1. Okay. Uh, C2 is also a straight line joining from 0, 0, 1 to so this was from 0, 0, 1 to 0, 1, 1. Okay. And C3 is also a straight line uh, joining from 0, 1, 1 to 2, 1, 1. Okay. So now we're gonna do the like we're gonna do a parameterization of these three lines, C1, C2, and C3. Okay. And then we're gonna just use the line integration formula to find out along each curve C1, C2, and C3. Okay. So for the curve C1, I mean for the straight line, I mean straight line is also a curve. So we can say straight line is a curve. So the parametric form will be just A plus G into B minus A. Okay. So here A is 0, 0, 0 and B is 0, 0, 1. That means this is just 0i plus 0j plus 0k plus t into this is so b is 0, 0, 1. So 0 minus 0 I plus 0 minus 0j plus 1 minus 0 k. So this is just 0. I mean just t of k. 0i plus 0j plus t of k cap. Okay. So now here t will vary from 0 to 1. Okay, because if you just put t equals to 0, you will get the point a bar, I mean the a cap, and if you put t equals to 1, then a will get cancelled out and you will get r of t to be the last point b. Okay, the joining point a and b you will get if you vary from 0 to 1. So this is simply t of k cap. Okay, so now from here we can see that x of t is 0. So this is implying t of x is 0. Y of t is also 0. This is implying t of y is 0. And z of t is t. So this is implying dz equals to uh, dt. Okay. So our integration C1 f dot tr. So this will be just f of rt r prime of t dt, right? So this is 2 into 0 plus 3 into I cap, and it was xz, so it will be uh, 0 into t j cap plus 0 into k cap. Okay, and then dot product of t k cap. So this is integration is whole 0 plus 0 plus 0 dt. So this is just 0. Okay. So now again along the path C2, the path was from 001 to 011. Okay. So our R cap of T will be 001. So 0i plus 0j plus k plus T times. So this will be 0 minus 0. So 0i plus 1j plus, so this will be again 1 minus 1 0 0k. Okay, so this will be just t of j, correct, where 0 less equals to t less equals to 1. Okay, then again c2 of f dot dr. So this is gonna be again t of k cap. So this is, sorry, this is 2t plus 3 into I cap plus 0 j cap plus t minus 0 k cap and this is dot product of 0 plus 0 I cap plus tj cap plus 0 k cap, and there will be this will be dt. Okay, so this is going to be 0 to 1 0 plus 0 plus 0 dt, which is just 0. Okay, and along the path C3, so the equation was it will be from 0 1 1 to 2 1 1. So R of t will be 0 I plus say plus k plus t times 2 minus 0 I plus 1 minus 1 j plus 1 minus 1 k. So plus 0 j 0 k. Okay, so this is just 2t I cap plus j cap plus k cap, right? So here xt is 2t, and this is implying dx equals to 2, yt is 1, this is y dy implying 0, and dz, sorry, z of t is 1, and this is implying dz equals to 0. Okay, and so just wait. Okay, so our C3 of f dot dr, so this is from 0 to 1, and so in this case it will be 2 into 1 plus 3 because z is 1, and then I cap plus it will be, since yt is 1, so it will be, and xt is 2t, so it will be 2t into j cap plus yt is 1, and this is 2t because it was uh, yz minus x, so yz is 1 and x is 2t, so this is, that's why this is into k cap dot product. So this is going to be 2 dt I cap plus 0 dt j cap plus 0 dt k cap. Okay, so this is just integration 0 to 1, and this is 5 I cap, uh, sorry, this is not 5, this is 2 times 5, which will be 10 dt, and all other will be 0. So this is 2t times 0 dt plus this is also 1 minus 2t times 0 dt. So this is just integration 0 to t 10 dt, and this is just 10t from 0 to 1. So this is 10. Okay, so integration of c f dot dr is just 10 plus 0 plus 0. I mean, not 10 plus 0 plus 0, 0 plus 0 plus 10, which is 10. Okay, so this should be the answer of this question. Okay, and now suppose it is given that C is the straight line from 0 0 0 to 2 1 1. Okay, so in this case our equation of the straight line will be r of t equals to, so this will be 0 I cap plus 0 j cap plus 0 k cap plus t times 2y plus a plus k, right? So that is 0 less equals to t less equals to 1. So simply 2ti plus j plus k cap, where 0 less equals to t less equals to 1. Okay, so here x of t is 2t, so this is implying t of x is 2 dt. Again, y of t is 1. So this will imply d of y is 0, and uh, z of t is 1. This is will imply that dz is 0. Okay. So integration over c f dot dr. This is going to be from 0 to 1. So this is x is 2t, yt is t, and zt is t. So this will be 2t plus 3 I cap. So plus this will be xz and yz minus x. So xz will be 2t square of j plus t square minus 2t of k, dot product 2 dt of I plus dt of j plus k dt. Okay. So this is just 0 to 1, 2 times 2t plus 3 plus 2t square plus t square minus 2t, and then dt. Okay. So this is just integration 0 to 1, 4t plus 6 plus 3t square minus of 2t dt. Okay. So this is 0 to 1, 3t square plus 6 plus 2t dt. So this is t cube plus 6t plus t square, 0 to 1. So this is 1 plus 6 plus 1, and which is 8. Okay. So in this case, the integration over fc f dot dr is simply 8. So I hope this is clear. So now we're gonna move on to the next question. So which is question number 7. Okay. So find the value of the work done by the force minus of x, y, I cap plus y square of j cap plus z into k cap. Okay. In moving a particle from 200 to 0 to 0 over the circular path x square plus y square equals to 4 and z equals to 0. Okay. So so the graph is given like this. So this is our xy plane, and they are taking this arch. This is x square plus y square equals to 4. So this is 2 comma 0 and 0 comma 2. Okay. Now since x square plus y square equals to 4 and z equals to 0, So we can write the parametric form as x equals to 2 cos t and y equals to 2 sin t and z equals to 0. Correct? So from here, dx equals to minus 2 sin t, uh, dt, dy equals to 2 cos t dt, and dz equals to 0, right? So here, since the arch is only on the first octet, so the angle will be just t equals to pi by 2. So it will be 0 less equals to t less equals to pi by 2, right? So the work done is just over c f dot here equals to 0 to pi by 2 minus 4 cos t sin t. Okay. So because the f is minus xy plus y square plus z, so this will be minus 4 cos t sin t I cap plus 4 sin square t into j cap plus 0 into k cap dot minus of 2 sin t dt into I cap plus 2 cos t dt into j cap plus 0 into k cap. Okay, so this is just 0 to pi by 2, 8 sin square of t cos t plus 8 sin square of t cos t plus 0 into dt, right? So this is just 16 0 to pi by 2 sin square of t cos t dt. Okay, so this is 16 times 0 to pi by 2 sin to the power 3 minus 1 t dt into cos of 2 minus 1 t dt, right? So this will be half into 16, so into so beta of 3 comma 2, sorry 2 comma 3, so 8 times beta of sorry, so this will be comma of 2 comma of 3 by comma of 5, so 8 8 into 2, mm, so this is 8 into 2 into 1 by 4 factorial. This is 16 divided by 24. Sorry. Okay, so this is gonna be 2m minus 1. This will be 1, and 2n minus 1 will be 2. So this m will be 1 and n will be 3 by 2. Okay, so this integration will be 16 into half into beta of uh, 1 comma 3 by 2. So 8 into gamma of 1 to gamma of 3 by 2 divided by gamma of 5 by 2, right? So this will be 8 into gamma of 3 by 2 into 3 by 2 gamma of 3 by 2. So this will get cancelled out and just be 16 by 3. Okay. So I did a small mistake here in the beginning. So I was just writing only like sine to the power m minus 1 of t and cos to the power n minus 1 of t. But it will be sine to the power like 2n minus 1 of t and cos to the power 2n minus 1 of t. And then only we can write in terms of beta function and gamma function. So this is just 0 to 1 cos to the power 2m minus 1 of t sine to the power 2n minus 1 of t dt equals to half beta of m comma n. Okay, so I'm using this result. So I hope this is clear. Okay, so now I'm going to move on to the next question. Okay, so if 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 the vector field f equals to x square y square plus 3z square of I cap plus x square z plus xy square into j cap, sorry, 2y square plus xyz into k cap, then find the value of gradient of divergence of f at the point 1 to 1. Okay, okay. So divergence of f is so this is just del x of x square y square plus 3z square plus del y of x square z plus xy square plus del z of x, y, and z, right? So this is gonna be 2xy square plus x plus xy 2xy plus xy. Okay, so this will be 4y because this is 2, sorry, so this will be 4y, this is not x, this is 2, and this is 4y, plus xy, because the integration with respect, like derivative with respect to z will be xy. So this is 2xy square. So yeah, this is value. Okay, and then gradient of divergence of f. So this is gonna be mm, del x of 2xy square plus 4y plus xy into I cap plus del y of 2xy square plus 4y plus xy into j cap plus del z of 2xy square plus 4y plus xy into k cap. So this is just 2y square plus y I cap plus 4xy plus 4 plus x into j cap plus 0 into k cap. Okay, so now gradient of divergence of f at the point 1 to 1. So this is just 2 into 2 square plus 2 I cap plus 4 into 1 into 2 plus 4 plus 1 into j cap plus 0 into k cap. So this is 10I plus 13j. Okay, so gradient of divergence of f at the point 1 to 1 is 10I plus 13j. Okay, so yeah, this should be the answer of this question. Okay, so now we're gonna move forward to the next question, which is question number 9. So let v var equals to, v cap equals to x square plus y square into I cap plus y square plus z square into c cap plus x square plus z square into k cap uh, be vector field. Then find out the value of this is gradient of v minus nabla square of v at 1 to minus 1. Okay, so solution. So now from the given relation, it is easy to verify that this h is just this is the nabla times the nabla cross. Okay, so first we're gonna find out the curl of v, which is the nabla cross v, and this is just I j k tilde x tilde y tilde z x square plus y square plus z square and x square plus z square. So this is I times 0 minus 2z minus a of 2x minus 0 plus k of 0 minus 2y. Okay, so this is minus 2z of I minus 2x of k minus 2y of 2x of j and minus 2y of k. Okay, so now h equals to, I mean the h vector h equals to uh, this the curl times the curl of v. So this is just I j k tilde x tilde y tilde z minus of 2z minus of 2x minus of 2y. So this is gonna be I times minus of 2 plus 0 minus 0 minus of j 0 minus minus 2 plus k 0 plus 2. So this is minus of 2y uh, minus of 2j plus of 2k. So this will be minus 2 minus 0. So this is minus of 2k. Okay. So our h is just minus of 2y minus of 2j minus of 2k. Okay. So yeah, I hope this is clear now. Now we're gonna up to the next question, which is question number 10. Okay. So find out. So find out the value of the line irrigation a dot here where the vector field is given by 3x square plus 6y into I cap minus 14y j cap plus 20x z square k cap, and c is from 0 comma 0 comma 0 to 1 comma 1 comma 1 by x equals to t, y equals to t square, and z equals to t cube. Okay. So here, our d of x is dt, d of y is 2t dt, and dz is 3t square dt. So over C, a dot dr. So this will be from t equals to 0 to 1, 3t square plus 6t square I cap minus 14 y into z. So y is t square, z is t cube. So this will be t to the power 5 j cap uh, plus 20 x is t, z is t to the power 6, and this is k cap, and there will be another dt. Okay, so this t will be from 0 to 1. So this is 9t square I cap. Sorry, this is not tt, dt. So this will be another gt into I cap plus 2t dt into j cap plus 3t square dt into k cap. Okay, so this will be 9t square dt minus 28 t to the power 6 dt plus 60 t to the power 9 dt. Okay, and this is just 3t cube minus 4t to the power 7 plus 6t to the power 10, 0 to 1. So this is 3 minus 4 plus 6. So the answer should be 5. Okay. So if the question is correct, so uh, integration over C a dot dr is just 5. Okay. So I hope this is clear now. So now we're gonna solve the next question, which is question number 11. And this question is also from the potential function. Like we have to determine whether the potential function exists or not. So the question is written as follows. Uh, Determine whether the vector field f of xy equals to 2xy plus 3x square into I cap plus x square plus 4y into j cap is conservative. Conservative, and if it is conservative, find a potential function. Okay, so now we're gonna do the solution of this question. Now to determine of a vector field, like whether it is conservative or not, especially for two-dimensional function, we have seen that if f equals to sorry, if f of xy equals to f1 of xy I cap plus f2 of xy j cap, uh, then this f is conservative if and only if del f to del x equals to del f1 del y. Okay, so here f1 is 2xy plus 3x squared, and f2 is x squared plus 4y. So now del f1 del y is just 2x, and del f2 del x is also 2x. So uh, from this scenario, we can say that f is conservative. So that means by previous result, it has a potential function. That means f can be written as gradient of phi. Okay. Now our job is to find out that potential function phi. So let phi be the potential function of f. Okay. Then f cap will be, or the vector field f is gradient of phi, and this is same as 2xy plus 3x square into I cap plus x square plus 4y into j cap, and this is same as del phi by del x into I cap plus del phi by del y into j cap. So now we can compare both the left hand and right hand side, and if you do so, we get del phi by del x equals to 2xy plus 3x square, correct? So now we can do the integration with respect to the variable x, keeping the variable y constant. So the constant term after the integration will be coming as a function of y. So phi of xy is gonna be integration 2xy plus 3x square plus phi 1 of y. Now this integration is with respect to x. So let me write d of x plus phi 1 of y. So this will be just x square of y plus x cube plus phi 1 of y. Okay. Now again we can do the derivative or the partial derivative with respect to y, because we have another information del phi by del y, which we can use from the previous equation. So here it will have del phi by del y equals to x square plus phi 1 prime of y, correct? Now what is del phi by del y? So from here we can see from star we have del phi by del y equals to x square plus 4y, correct? So we have phi 1 prime of y equals to 4y, correct? Or in other words, phi 1 of y is 2y square plus some constant c. So now we can substitute this phi 1 of y, and we get our required potential function phi of xy as x square of y plus x cube plus phi 1 of y, and which is 2y square plus c, and of course where c is a constant. Okay, so this is our required potential function of the given if. Okay, so I hope this is clear. And if you have any questions, please go through the video again, and then again if you have any doubt, you can ask me in the next class. So yeah, thank you, and see you in the next video.